Describe the slope of each line as positive, negative, or zero. For line Q, you can see it starts on the bottom left and increases as we move to the right. So since it's going up as we move from the left side to the right side, this has a positive slope. The rock climbing situation in the video can be represented by a function that relates the time in minutes and the height of the rock climber above the ground in feet. What is the input of the function? We are inputting the time in minutes, and the output of the function would be the height in feet. To sketch the graph of the function, we would put time on our x-axis and the height on our y-axis. So she started at around 50 feet and she descends, and then she takes a second pause, some pause, and then she goes back up to the 50 feet. She doesn't quite make it to the ground, so it won't go on the x-axis before she paused and started climbing back up. This happened at around 4 minutes. That's when she paused and started to turn back around. Here is a sketch provided from the teacher's edition. For problems 2 through 8, describe the function by using any of the following labels: linear and increasing, linear and decreasing, nonlinear and increasing, or nonlinear and decreasing. This one is forming a straight line, so it will be linear. And since it is going up, it is linear and increasing. This one is not a straight line, it is a curve, so it is described as nonlinear. And the curve is having a downward trend, so nonlinear and decreasing. Number 4 is also a curve, so it is nonlinear, but it has an upward shape, so it is nonlinear and increasing. And this last one is straight, so we can describe it as linear, and it is sliding down as we move from the left side to the right side. so it is decreasing. We can see as we move up the x-axis, we also increase in the y. So this is an increasing function. Now to determine if it is linear, we need to look and see if the rates at each interval of time are the same. 10 minus 7 is 3. 1 minus 0 is 1. So that would have a slope of 3 at this point. Here, 13 minus 10 is 3, and 2 minus 1 is 1. So that also has a slope of 3 there. This one increased by 3 and 1. And this one increased by 3 and 1. So this is a linear and increasing function. As we move up the x-axis, this one is also getting larger, so it is increasing. From negative 7 to 2, that is a difference of 9. 2 minus negative 7 is 9. 1 minus 0 is 1. So at this point, it has a rate of 9. Here, from 3 to 2, that was a change of 1, and a change of 1 here. But 1 divided by 1 is not equal to 9. So this is non-linear because the rates at each point in time are not the same. This one is a curve, so we know that it is non-linear. And at the start, it is increasing, and then towards the end, it is decreasing. Until 3, it increases, and then after 3, it decreases. So as time is passing, this roller coaster increases in height, then decreases in height, increases, and decreases again. So it says a roller coaster car travels along a track and does 2 upside down loops. Sketch the graph of the function that represents the time and height above the ground for the roller coaster car. Now, time is passing and the height is going up, but it doesn't go back in time. Even though our roller coaster appears to look like this, we don't want to go backwards in time. We want to continue moving forwards in time. So it starts down at the bottom, but it's not quite at ground level, so we might start it just above. And as we go through, it goes up, and then it comes back down, and then it goes up again, and then it comes back down. Again, the reason that we don't draw the loops is because we're not going backwards in the seconds. We're still moving forward in time. So if you drew 2 loops in part A, it says to create the revised version of the sketch of the graph of the function that represents the time and height above the ground for the roller coaster car, which just means if you made a mistake and did the 2 loops in part A, revise your sketch to draw it constantly moving forward in time. Here is the actual graph of that data. You can see that it starts to go back up in the second loop at around 5.5 seconds, right there in the middle. Is the function represented by the graph linear or nonlinear? Well, this is not a straight line, so it would be nonlinear. Where is the function increasing? Well, the function increased from 0 to about 3 seconds, and then from about 5.5 seconds to about 8 seconds. Where is the function decreasing? Well, it decreases from about 3 to 5.5, and from about 8 to 11. That takes care of lesson 9 about increasing and decreasing functions. Check back here for more videos.